This is the LogixPro software. Please note that you have to have the CD-ROM in the drive in order to run the software. It checks for the license on the CD. One of the first things you'll want to do is change some settings, because there's a couple things that can be really annoying. I'm going to unenable sound. There's some cheesy sound effects that go with the various simulators. You probably don't want to hear them. If you want to, you can leave it on. I'm going to turn it off. But just know that if you mess up in the simulation, sometimes you start a virtual fire and alarms go off and make a lot of noise. So just be warned that your computer may all of a sudden make a loud noise. Also, there's a little character called Merlin. He's supposed to be a little helper. This is a program back from the 90s. And during that time, there was this little character called Clippy that Microsoft had made, and a lot of people were trying to add little characters to their software to make it look more friendly, and you don't really need it. The funny thing about Merlin, though, the character, if you leave him on, he'll go to sleep and he'll snore, and you'll hear a sound coming from your computer, and you'll wonder what on earth the sound is. So I just turn off sound and Merlin because my focus is on PLC programming. The software, like I said, is a little bit dated, but it's one of the, I haven't found anything quite like it. It emulates Rockwell Automation ladder logic language, which is really good. It's very close, looks very much like Rockwell Automation programming. But it also simulates the system to be controlled. So rather than having a PLC sitting off to the side that you're programming, downloading to, and then controlling and interfacing to a real system, this is all built into the software. So it's a nice setup. I like it. I wish something like it would be made today that's in an updated format. But if you close the simulator window, you'll see what you would see very much like what you would see in Rockwell Automation software. I won't go through and describe what all these things are. We'll learn them along the way. But this is sort of an information window, and if you close it, it comes back to the simulator. You're not really closing anything. It just cycles back and forth between the two windows. The various simulations are available here, so the systems that we want to control. For example, the door simulator. I thought I told it to disable sounds, but I guess it didn't want to. Maybe it will disable sounds when a mistake has been made. Anyway, so various simulators are available. This is a door simulator where you can make the door move up or down by activating the appropriate output. There are limit switches to detect the door's position. There are buttons for input, and also besides the motor there are lights for other outputs. It's as if what you're doing over here in this ladder logic area is programming this PLC that's hanging on the wall that's interfaced to all the switches and the motor and so forth, however is necessary to control those items and to take input from them. And you'll notice that there's an input and an output sort of number here, and the upper number for the input is 001CH. The H indicates that this is a hexadecimal number. So the 001C is actually the number, and C in and of itself being a hexadecimal number, remember we've got the numbers 0 through 9 plus A through F. The C represents the status of 4 inputs. That's a whole nibble worth, right? That's 4 bits, 4 input bits. This is just a nice compact way of displaying the input status. So for example, if we go to calculator, and then change to programmer view, then hexadecimal, C is 1100. What that means is that input 0 is 0, input 1 is 0 or off, input 2 is on, and input 3 is on. That's how you read this and interpret it. So the 1 next to that C, that's actually a hexadecimal 1. So it's still 4 bits. So changing that over to binary, calculator's not going to do it the way I want it to, but it's still 4 bits. So it's really 0001. Okay, so that means that the next input is on, and then 000. There are 3 more zeros that this hexadecimal 1 over here represents, indicating those other 3 are off. There's another nice feature here. You can go up to this little hammer and wrench, and when you click on it, you can actually see the memory status. Let me show you what I mean. If I go to the inputs. We're talking about the inputs are 001C. Well, if I go to the inputs and view this in, they don't have, there we go. Okay, so I'm not running the simulation. Let me run it. Hang on just a second. So we'll run, and you see that the value matches what's over here now because the PLC is actually in run mode. So when I'm looking at the memory, it's accepting the input status and updating the input word. So 001C matches. Well, that's in hex. If I change to binary, these first 4 bits here are the C. Okay, so 0, there's no 1s, no 2s. There's a 4 plus an 8. That's 12, but in hexadecimal it's C. And then the 1, the next number over here, this one right here, that's 1000. Okay, so that means that input 4 is on, input 5 is off, input 6 is off, input 7 is off. And then these 2 zeros here are both 4 nibbles apiece. So that's the remainder of the word, the last 8 bits here. So it's just a compact way of showing the status of this whole input word without needing 16 different digits. That's all that really is. And then the outputs are similar. So right now no outputs are on. If I go to the output table to look in memory, so I'm looking inside of the PLC's memory here, well, none of the outputs are on. They're all zeros, and so it's not a surprise that we've got 4 zeros over here in hexadecimal, each 0 being a nibble. So that's 4 times 4, 16 bits, and you can see all 16 of those bits here and that they're all off. So that's how that works. Now, you might notice there's this place where we can go back and forth between the command palette, where you can grab different commands. So, for example, you can grab an examine instruction and address it. I'll show you how to do that in the context of example problems, but you can put outputs on the rung and create a ladder logic program here to make it do, whatever you want. You can decide how you want this door to function, or any of the simulators as you go into them. Speaking of simulator, oh, I know what I was going to tell you. So also up here going back and forth, you might look at this and say, well, wait a second, why do I have to download? What does it mean by download? Am I grabbing something from the internet? No, remember that this system is simulating you having a laptop with Rockwell Automation software where you can make your ladder logic program, but then you have to connect that laptop to the PLC to download the program to the PLC. That's what this download button represents. Once you've written your ladder logic, you can hit the download button, and then and only then does your code go into the PLC. And then you have to put the PLC into run mode to make it start controlling the physical system over here. Okay. So there's a lot to know here, but it's like I said, I really like this software, even though it does look a bit dated. The other simulations that are available, there's a silo simulator, and this is a simulator where you have to program it so that this box comes over, the solenoid valve's open, and it's filled up with whatever the stuff is. It's pink, and then you move the box on. You have to program the start-stop buttons and all of the lamps and so forth. There's a traffic simulator. And so you've got some sensors in the ground. That's, for example, 1/2, I:1/2. That's a sensor to sense cars going along this way. And then another sensor, I:1/3, to sense cars going the other way. And then a bunch of output lamps. And of course, this is basically the classic timer type problem where you're trying to time stoplights. It can be a little bit annoying once you run this simulation. Once you put it in run mode, 2 things actually happen. Not only does the code in the PLC start, but also the simulation of the real system itself also begins. So right now you'll notice that we've got a car flying through the intersection because there are no lights. So I guess these people think it's okay to just go. And we have an option to park that car, so there is some manual control of the simulator and what's going on in it. You can unpark the other car, and if you unpark both, there's a chance they'll crash, and fortunately I've turned off the sounds. Otherwise you'd have heard a loud tire squealing crash noise. And you see that the simulator after a period of time resets so that you can try again. Now you can change the speed of the simulation, and really what you're doing is changing the scan time, making more scans, or well, more time per scan, or you could look at it as more scans. And that slows down the simulation. That can be very helpful because you can really try to understand what your program's doing and why it's not working. You can also step through the program. And this is a single scan, so if you know anything about PLCs, you know that they scan through the entire ladder. And so what this single scan button does is it allows you to look at your code, go through one scan of the code where the PLC grabs the inputs, calculates from your code what the output should be, and then sets the outputs, and then stops so that you can see how things are progressing and changing. So the simulator also goes in step with the scans. And you can see that as the car slowly is moving as I continue to hit the single scan button. There are several other simulators, a batch simulator. There's a simulator that's actually really useful for testing your code. It's called the I/O simulator, the input-output simulator. And this input-output simulator has several different inputs, and you can change the switch type. If you right-click the switch, you can change the switch. There's a normally opened switch, and if I press the button, it toggles and stays in position. So I'm pressing the mouse button and releasing. You can change it to a momentary switch where you have to hold it down with the mouse button. As soon as you release the mouse button, it opens back up again. If I right-click, this is a normally closed momentary switch. So if I hold down the mouse button, it opens up the connection, but once I release it, goes back. And you can change to a momentary let's see, what is it called again? They don't tell us, but it's a momentary toggle type switch. Same thing here. Normally open, normally closed. So you can see some of these have already been changed. Another thing you can do in simulating this for the outputs, you can actually change the color of the lamps. So when this lamp comes on now, it'll be red. The default is yellow or amber. And then there's another whole bank of inputs over here on a different input card, more outputs. And then there's what's called a binary coded decimal input wheel here, where you can change the numbers here and input a binary coded decimal number into input 5, where 5 is a whole word. And you can also write out to output 6 in binary coded decimal format, and it will display whatever number you've got in memory. Dual compressor simulator. Oh, the I/O simulator is particularly useful for troubleshooting your code, and so you can, a lot of times when you're writing a fairly large ladder logic program, it can be difficult to write the whole thing at once. It's better to take the program and break it down into smaller pieces. And so when you're trying to program one little piece, you don't really want to run it and make it try to control the real system. What you want to do instead is just put the code in, see if it works, and see if it does what you think it should, and that your algorithm is working, and then use that code. So that's really what the I/O simulator is for, so you can just trigger inputs and see if the outputs do what you want them to do. The bottle line simulator is a real nice, fairly large, involved simulation. It's a simulator where you've got glass bottles. Some come in broken, some are tall, some are short. And depending on whether they're tall or short, you fill them with either, it looks like orange soda or grape soda. Then you put a cap on. If they're broken, you have to open a trap door and grind them up to put ground glass into a box, but the boxes do fill up. Also, once you've capped and filled them, when they come over here, you need to sort them so that the large bottles go one way and the small bottles go the other. There's also some counters down here for counting how many scrap bottles there have been, how many boxes have been filled, how many large, how many small bottles have been filled and manufactured. And there's an extra enter button, a counter to count numbers, so you could, if you wanted to make a program in the PLC that controls the system and only generates 10 boxes of glass or maybe 20 tall bottles of filled fluid, you could set that here and make your program work that way. There's start and stop buttons, and then an indicator lamp, and then a selector switch down here that you can add into your program. Now, of course, you have to make the program to determine how this works. Along the way, there are some useful sensors over here. This sensor senses broken bottles. This sensor is simply a limit switch, and when a tall bottle comes along, it triggers the limit switch. And then this is a bottle presence sensor, so you can tell whether you're between bottles or on top of a bottle. And indexing the bottles in this simulator is one of the key starting points for making this simulator work. The elevator simulator is another relatively involved simulator, not trivial to program. It's a 4-floor elevator. Not only do you have buttons inside of the elevator for patrons in the elevator to request a floor, but you also have buttons on the outside of the elevator, just like a real one, to request service at a particular level in a certain direction. There's a motor here that you can control to move the elevator carriage up and down. There's another motor over here for opening and closing the doors, a couple of limit switches to detect when the door is open and closed, a stop and call button inside the elevator, as well as a selector switch. One interesting thing about this is there aren't really limit switches at each floor to say, okay, you're at the floor. Instead, there's an encoder. And so you have to look at the encoder number to tell where the elevator is, and you can see that. I think it's right here, if I remember right, on input 5. Now, you can actually send the elevator too far down or too far up. It has a little bit of over travel. And there are some switches at either end to detect that the elevator has reached the end of travel. But again, this is a fairly involved simulator. So this is a pretty good program. I'll probably make a separate video to show you how to combine programs, because when you save code in this program, you save your ladder logic, it saves it as a RSL file. So the extension is .rsl. I think it's going to save it. It's strange. Anyway, that RSL file, as it turns out, is actually just a text file. And if you and other people are working in a group on a large project, you can actually write your code and combine your code in a program like Notepad, a very simple text editor. I don't know why it's going so slow. I think it's having network troubles. So anyway, yeah, you just save them as RSL, and then you can, that's the default format. And then you can open them up, like I said, in a text editor and combine. But I'll make another video showing you how to do that. And it looks like my computer is having trouble accessing network drives. That's why it's going so slow. So that's LogixPro. Like I said, it emulates Rockwell automation programming and includes some simulators that we can use to learn how to program well.